After today's lecture.
So
Okay.
submit the assignment to the e-learning, please.
Okay, sir.
Take your attendance, okay? The attendance, and then the assignment here. Okay, submit your assignment here. Okay, and then the presentation either later or next week. Okay. So now we start our lecture with the. I try to cover 2 topics because we are behind. Because of public holiday. Okay. Now we cover today we cover cloud service model and cloud architecture together. Okay. Can you see my screen? Can you hear me? Can you see me? If yes, give me 1. Okay, thank you. The objective of cloud computing, as told you before, important is the elasticity or scalability. Either we can scale up or scale down easily, as easy as possible according to our demand. Okay, and on demand usage, okay, ability to add or delete computing power, okay, and storage according to demand. Okay, for those late, please share I share one more time, and then for those late, the attendance, the password, please share. I share this one on the chat, and then your assignment, please put it on your e-learning. On e-learning password. Okay, now I share the password. For those latecomer, please tell them the password for attendance. Okay, and submit the assignment to e-learning. And next week, again, remind you all, the test will be there. Okay. So on demand, because when we need it, then we can add the CPU and so on. So on demand usage here, the second part is almost the same as elasticity. Okay, but sometimes elasticity you can have according to application or according to load. Okay, sometimes the application, the load is getting higher and so on, then it can on the spot, you can do that very easily. Okay, and pay per use, pay only for what you use, and there are many subscription model, and multi-tenancy, ability to have multiple customer access their servers in the data center in an isolated manner. This is a multi-tenancy is from the perspective of this supplier, service provider. Okay, and same from a perspective of consumer. Sometimes you can subscribe to different vendor as well. Okay, but multi-tenancy here refer to from the point of view of the cloud service provider. They able to support many customer, and then their server can support them even within the same server, because they can use an isolate virtualization. Okay, cloud characteristic: on demand self-service, broad network access, resource pooling, rapid elasticity, and measured service. Okay, these are some basic characteristic. Cloud business model: pay per use, perpetual license, or renewable license. Okay, so most people use the pay per use. Okay, but for the licensing is more for the certain platform as service. For example, platform as a service. You want to subscribe to certain uh, cloud computing services that can be used for your application. Okay, and they might use a license base. Okay, advertising funded, or sometimes they give you free because they can get the revenue from advertising. Like you watch YouTube channel, either you subscribe, you pay them, uh, try to have premier service, I mean without any advertisement, because you pay them. Or if you want to use a free one, then in the middle of your movie or in the middle of your YouTube channel movie, then or whatever video, then the advertisement can pop up. Okay, so they would, because they need to fund their server through other advertising revenue. Okay, bits to object and the value added for existing product, build a user community. Okay, bits to object depend on how they charge you. They charge you by the smallest one is the bit, as you know, how many bit involved, mean in terms of file size, in terms of bandwidth. Okay, how many bits, megabits, or how many storage, or to objects, whether they provide you particular object in terms of huge database object, or certain movie, or certain how to say services which describe an object. So they can charge you accordingly to different models. Okay, and three cloud service model, basically software as a services is the highest level. So the capability provided to consumer is to use provider application running on cloud infrastructure and accessible from various client device through a thin client interface such as web browser, or the consumer does not manage or control the underlying cloud infrastructure, network server, and others. Okay, with possible exception of limited user specific application configuration setting. Okay, so meaning through like especially this happen to those that use a smartphone. Okay, those that use a smartphone, they install a lot of, for example, either iPhone, iOS, or Android phone, smartphone. They install a lot of Android apps or smartphone apps. Okay, then through the smartphone, they can access to the services needed. Okay, for example, your Google Map or Waze, 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 to navigate from one place to another place. What else? Grab, delivery, and so on. Some through browser, for example, you can Airbnb, okay, or travel. You want travel, you want book hotel, booking.com. So these are example of software as a services. So user just navigate through the user interface of web browser, without control the server and so on. Okay, another one is a platform as a service. The capability provided to consumer is to deploy onto the cloud infrastructure consumer created application using programming languages and tools supported by the provider. Okay, like for example using Java, Python, .NET, and so on. So they are, for example, what kind of platform? I think one popular one, I think Cloud9, IDE. So you also can write your Python code or whatever, and then run on the cloud. And it's some sort like IDE, cloud IDE. And then you can compile it, troubleshoot your things, or you can use certain um, how to say, middleware or services like database software like Mongodb, Cassandra, or Oracle, this kind of thing. Software as a platform. Then from there, you build your application using this software to keep your tables and so on. Okay, you build your GUI and so on, also on the cloud, and then able to come out an application. So you don't need to have install your IDE compiler, your databases there. Okay, some are more particular. They try to support certain specific service. So if let's say you want to build inventory, application inventory or sales, how to say, order inventory order and so on. So these are our accounting, marketing software. So they have certain common services across different industry, and all these common services, some company also provide it as a platform, as a services. So you do need to write certain common what or we call horizontal services that across different domain, manufacturer or office, they might use a or retail or whatever, manufacturer, retailer, or what other industry, different industry, but they uh, have a common requirement for the apps. For example, they need to maintain their inventory. They need to manage who order what. Okay, the customer relationship. So some are called CRM, customer relationship management. Okay, some are called what the supply chain management, or the resource uh, planning. Okay, the resource inventory, resource planning. So this kind of thing, for example, certain company are very good at it, like SAS or Salesforce. They provide a certain module to do this kind of thing, inventory or ordering or this thing. So the user also can use it to build a specific web page or specific apps based on these common services. So these are also one type of platform as a services. Okay, and last but not least is a cloud infrastructure as a services, IaaS. So these are like Amazon, okay, uh, AWS, which provide you the basic uh, uh, element or resources like storage, network, and CPU processing, or GPU and so on. So you can subscribe, create virtual machine, create Docker and so on top of this. So these are three models. Okay. So software as a services. Okay. The end user just see the user interface. Okay. And the platform as a services, they see application developer, more for application developer, and infrastructure as a services, more for system administrator. Okay. Okay. So you can see the differences. Okay, these are also the service model architecture. So when you come to PaaS, you can sit on top of IaaS. You can subscribe to different vendors, okay, or they can come from same vendors. They can come from same vendors, and they can pack everything together that you won't see them. Okay, or you can see them. Some you can see from the left hand side, you can see each layer because you subscribe to each layer also, for example. Or you can't see them. You just just use it like to your right hand side. If you use SSAA, you just see SAAS. You use PAS, you just see. So you can have individual each layer, or you can group everything together. Okay, and then you can't see them. Okay, so if, for example, you not use cloud service, then in traditional IT, actually you need to manage everything, ranging from application on the top towards the bottom, like networking. Okay, and for the infrastructure, okay, for infrastructure, you are just manage your middleware runtime and your data application, and the rest are, for example, deliver as a service by your service provider, such as operating system, virtualization, server, storage, and networking, handled by the vendors. Okay, if, for example, you subscribe to AWS, so the gray color stacks, you do need to worry. You just worried about blue color stacks, software stacks. Okay, when you use platform as a service, then you manage your application and data. Okay, the rest are managed by service provider. Okay, if you do it as software as services, everything delivered by your service provider, you don't need to worry anything. What you use, you just navigate by using your mouse or by touch screen. Okay, either by navigate by mouse or touch screen or keyboard. So you through the user interface only. So without worry anything, because this is the highest level. So if software as a services actually is, we call it is a 100% transparent. Okay, so user didn't know how it do, what after install they just use, and they cannot differentiate actually the service is run on their notebook, on their PC, or actually through network contact, get the certain data from the server in the on the cloud, or actually everything on the PC. They didn't know. For them it's exactly the same. Okay, so what's out there right now is, for example, infrastructure as a services. Popular one is, for example, Amazon. Okay, they put, for example, EC2, S3, okay, Elastic Compute Cloud, Simple Storage Server service, and Simple Queue service, and they also have payment and billing, and they have search and so on. Okay, so another company is Rackspace, also popular one. Okay, and they come out the product. Okay, and the platform as a services, for example, Google Apps, they support Python, they support Bigtable, Heroku, Ruby on Rails on EC2 hosted, Force.com, I mentioned like Salesforce. Okay, and Bungie Connect and Microsoft.net. Okay, Azure. Okay, for example, these are the Azure service platform, internet cloud service hosted in Microsoft data center, provide you OS and set of developer service, can be individually used or together. Okay, so you can have, for example, Live, Office Live, SharePoint, okay, .NET services, SQL services, Microsoft CRM. Okay. Okay, three features of SAS services. SAS is a hosting application on internet as a services. Features of matured SAS. Okay, scalable. It can handle many people. Multi-tendency. One application may be serving hundreds of company, and opposite of multi instance, where each customer is provisioned their own server running on one instance. Okay, and they have also metadata driven configurability. Okay, instead of customizing app for a customer, so they can easily configure for different users. Okay, so these are more towards how, if how to consider whether your software as a services good or not, because we don't want everything hard coded for each consumer, right? So if everything hard coded for each consumer, you cannot grow, you cannot support global market. This is want to aim for global market and not local market. Okay, so if you want to target for global market, you must able to have this characteristic. Okay, so for example, on the software as a services, you can see, okay, these are some example. Okay, level 1, level 2, level 3, level 4. Mean the more you matured, the more matured you are, your software are more easy to use and able to serve many users. So if for example, let's say your boss asks you to migrate your application from traditional IT center to cloud. So maybe you initial stage you go to level 1, level 2, okay, and slowly you move to level 3 and level 4. Okay, so these are example of what's the difference between level 1, 2, 3, 4. Okay, so and users, because for users you hey, okay, Tiban, anything? You raise a
Uh,
hand. Yeah.
so, Doctor, one thing
Yes. Cannot hear you. Can you repeat?
hello, hello, doctor.
Yeah.
Yeah. So the thing is that I wanted to ask about the IaaS, PaaS, and also the SaaS. So does it come like a sequence? So it will be like the one P is like on slide. Just
Not necessary sequence. I mean
on slide
usually
number 7.
platform usually are low, infrastructure are lowest level. Okay, for example, let's say I'm a developer. Okay, I want to build software for my customer. Let's say V lah, especially V as a computer science student. And then your company asks you, oh, okay, can we move our application to clouds? When we move our application to clouds, then one thing is the infrastructure. Do we want to use the public cloud infrastructure or not? If you want to use the public cloud infrastructure, okay, then we don't want to use the platform. We want to use the public. I mean, I want virtual machine only. I want to install virtual machine on that one. Then the rest is I own my own license. I have my own Oracle and so on. So I don't want to use that platform because I buy the license already in my uh, in my traditional IT center. Now I want to migrate. So maybe I already have the software license. I already have software. So I just want to install on the cloud server rather than local server. So in that sense, I just subscribe to IaaS. For example, let's say you don't want even not even want to bother like this one this step, you not even want to bother about database because you want to use their database. Okay, let's say either Oracle or SQL Server, Microsoft SQL Server, or Mongodb, no SQL one. You don't want to install yourself, you want to use them, everything them. So in that sense, then you use directly platform as a service. Then but they charge you the higher, maybe more expensive or whatever, because the charging model is different now. Either virtual machine or your database, you need to pay extra on database and so on. So you can work on platform as a service. Then for software as a service, even we are developer, sometimes we can subscribe to but very rare we subscribe the software as a service, because usually when we as a developer, we call API only. We call through API or through web services, XML or whatever. So we are not directly using a GUI one. So usually we are not subscribed to software as a service. We either subscribe to platform as a service that they put or infrastructure as a service. And then for the end user only, they are, let's say your company lah, you want to build, you don't want to ask your developer to build the software because the software on the cloud can solve your problem. You just configure the name only, certain name only, then it allow you to configure on the, like for example, let's say I'm using e-learning that I share to you. For example here, I using this website e-learning, right? Student password and so on. So we do need to write our own. So we are using this e-learning, this one. For example, me as a user, I can configure what day I can upload my slide. I can set my assignment. So in this case, I use it as a software as a services. Software as a services because I directly use them as a software. But for example, I want to, as a developer, I want to install this software myself as a what I say, as a as an administrator. So I not even want to this one. So I might have only one virtual machine. Then I go to download this software that, and then I create basic e-learning, and then let the lecturer to use it as end user. So in that sense, I might only subscribe infrastructure as software, and then I install this whole thing myself. Okay.
Okay. Understood.
You get what I mean? So
Yes,
it depends on the needs lah. So I forgot this e-learning one called what this software. Anyone? No, this software. These are open source software. Anyone know this? Huh? Moodle. It's called Moodle. Okay. Okay. So if, for example, I want to install Moodle myself and so on, then I provide infrastructure as a service. If I want platform as a service, mean you subscribe to Moodle, I give you Moodle, and then from there, you don't need to install Moodle. Mean my website already got Moodle, and then you just configure. Okay, I configure for this semester and so on. Mean you are Moodle administrator. You create a Moodle and so on. Then you allow how many user use it. So if you are Moodle administrator, okay, then you are you subscribe it as a platform as a services. What platform? Moodle as a platform. Because you not even install Moodle, Moodle is already on the cloud. Okay. So I use e-learning as a 3 example lah. You can do any model. You can do infrastructure as a service or platform as a service if you use as a Moodle administrator, or you end user. If I am end user only, then Moodle e-learning, like just now I'm an end user, then I am as a software as a services. Okay. So these are highlight what your question is lah. Actually, it's not the sequence, it's the needs. If you want to manage all, then you go to traditional. If you want to manage only middleware, then you go for platform as a service. You want to manage you manage middleware, also you infrastructure as a service. You don't want to manage the middleware, then you can go for software as a service. Okay, so basically like this lah. I'll show you. So no more question, right? Then if you want to deploy, also you can choose private cloud, public cloud, or hybrid cloud. Private cloud mean you do everything on your data center. You own your data center. You don't own the hardware, but your company have many departments, and many branches. So you have headquarters and branches and so on. So you can actually consolidate your company resources and then able to serve more departments and different branches across the different geographical area. For example, let's say you create a company, then you establish in China, and then you are expand your business to Southeast Asia and to Africa or Europe. Then you create that, and but you able to use private cloud. So you actually don't each branches that you create your company, you buy all IT facility. You buy your data center in every branches. No, don't need. So you can make use of the uh, uh, a lot of resources here in the headquarter, and then the branches use only end devices, okay, or edge devices, okay, such as the notebook to browse the website of the company and so on. So in this technology, then you can call it private cloud. Mean they are access to your consolidate resources in headquarter or in data center that you share among different branches, different department. Okay, but you didn't make use of public cloud. Public cloud mean you make use of like Microsoft, Google, Amazon. You directly subscribe. Even server you do want to buy. The server you buy directly from, for example, AWS as an infrastructure as a service. Okay, hybrid model actually they combine between the two lah. You combine I say combine your private resources and public resources. Sometimes it's good to combine. Why? Because you move from legacy, move from traditional IT infrastructure towards cloud. So you don't actually throw away all your machine. So you still keep your machine and certain thing extra, for example, extra workload, extra people, department and so on. You don't want to buy new machine, and you use a new machine in the cloud, okay, rather than you buy it, you own it. But certain old customer or all users and so on stay on your old machine, you maintain it. So you slowly, how to say, migrate by through application domain or through new customer, new record there. So you can plan your migration from private to public, okay, and so that you can have a hybrid model. Okay, some also hybrid model because of cost also. During the non-peak hour or whatever, where most of the usage the company can handle themselves, so they do need to subscribe to cloud. Only certain peak season and so on, when it more than that, then you go to public cloud, and they're willing to pay because it will generate income through better serving the customer better. So they, in that sense, hybrid cloud also can be used because maybe 80% they can handle themselves already by local machine. So only 20% will go to public. Okay, so depend on your requirement needs lah. Okay, common cloud characteristic. Cloud computing often leverage massive scales, homogeneity, okay, virtualization, low-cost software, geographic distributed, advanced security technology. Okay, so these are leverage mean use on top of this thing lah. Why I need cloud computing? Because I want massively scale, and my thing is most of the resources are quite homogeneity, mean I'm using a same platform, so I can move around. Okay, and then I use virtualization to easy to manage, because virtualization can have a high isolation as well. Okay, and low cost software and so on. Okay, So cloud computing users and providers. So cloud provider to SAS software as users web application. So it can go from one level to one level. Okay, as I see. So Amazon EC2. This one EC2 is elastic compute cloud. Basically is you create your virtual machine on the cloud interface to create a virtual machine. So it enable you to create whatever virtual machine you like. You can configure it and then allow you to do so. Okay. And they have Amazon machine image AMI. Okay, is here got AMI or not? I think it's the Amazon machine image, right? Then you can launch this machine image to become instant. So image is passive. Image is like a file. You download your operating system, okay, and it's just a file. Until you install it and you run it, it become become a machine. It become a server. So same when you install certain software, you download it as a zip file or whatever file. If you didn't install and run it, then it remain as a file. Okay, until you install and execute it, then it become instance. Okay. So your instant, so your one image can have multiple instant depend on how many times you launch them Okay. Okay. So you can have same virtual machine image. So you launch 3 times mean you have 3 instance Image, of course, they can have different property Even they have a similar image, they carry different property. Example of property is the machine name, machine IP address, and so on But the file, the image is the same. Like you download your OS, okay, Ubuntu or Windows, it's the same one, right? And only you need to configure their properties only. So when you configure a property, they become different as different instance Okay, for example, student is the same class, but you have different object, student 1, student 2, student 3 So the image is like a class, instance is like object. Okay, so you can have high extra large instance, or extra large high memory. So you can choose your configuration whether you want high memory or high CPU. Okay, and they have a setting for you to choose. Okay, of course, extra large you need to pay more cost you more. Okay, compared to small. Okay, anything? So Amazon publish many AMI contain common software configuration for public use. Okay, in addition, members of community have published their own custom AMI as well. Okay, so if your application is website or web services, your AMI could be pre-configured web server. Okay, or the associated static content and the code for all dynamic page. Alternatively, you could configure your AMI to install all required software component and content itself by running a bootstrap script as soon as the instance start. As a result, after launching the AMI, your web server will start and your application can begin accepting requests. Okay, so you how to say, you here is the you can configure your AMI or you can have everything pre-configured. Of course, pre-configure is easier okay. So Amazon Cloud region and zone, okay, Amazon has data center different area of world: North America, Europe, and Asia. correspondingly, Amazon EC2 is available to use in different region. Okay, by launching instance in separate region, you can design your application closer to specific customer. So don't choose wrong region. It will penalize the performance and cost you more. Okay, because it need to across the different zone and so on, different region. Okay, so for example, we are in Asia, right? But sometimes you choose, for example, US region and so on. Why sometimes even we are in Malaysia, supposed to be Asia, but we choose US. Why? Because sometimes most of the free one, the default is US. Okay, so if you choose a certain free service before you really want to commit to your this one, then you have to choose the default one. Okay, so each region contain multiple district location called availability zone. Okay, and each availability zone is engineered to be isolated from failure in other availability zone and to provide inexpensive low latency network connectivity to other zones in the same region. By launching instance in separate availability zone, you can protect your application from a failure from a single location. So these are more for disaster recovery or contingency planning. Okay, for example, power outage to one area, suddenly got flood, suddenly got lightning and so on, then causing the power outage to the whole location or that building, to your data center building. Okay, so if you use a different availability zone, of course they are across different street, across different building. So and they have certain kind of criteria. How far should one zone to another zone? Okay, so the Amazon will define themselves, maybe more than 10 kilometer or more than the exact figure I don't have, but they have certain criteria so that you want to create a new zone, you have to how far away from there. Okay, cannot be same area, cannot have the same postcode, for example. So these are other criteria they decide more for the disaster planning. So Amazon Cloud EC2 storage, okay, so can have the elastic block store or instant store or simple storage service, okay, for the storage. Okay, so for elastic block store, okay, the simple storage service is just like you already had one hard drive with file system. So what you want is to keep your file there, to keep the file 1, file 2, and so on. Then it's like S3 lah, simple storage service. But let's say you are giving a hard disk, then you want to configure them into block, as many block, how many volume, and so on and so on. So you want to see them as a block store so that you can install your DBMS there directly on the block, or install your OS operating system, because you don't want to keep file only. You want to use that as a hard drive. Okay, so you go more low level, then you use the EBS lah. Okay, so they are different level. Okay, so EBS volume breaker in storage also for provide instance with persistent block level storage. Amazon EBS volume are essentially hard disks that you can attach to a running instance. So you look at like virtual hard disk lah. Okay, Amazon EBS is particularly suited for application that require like database, file system, or access to a RAW. So you want to install your own file system. Okay. So to keep backup copy, you can create snapshot. Okay, you can create a new Amazon volume and so on. So if you play with hard disk, of course you need to backup. So for us, if we buy hard disk in real hardware resources, normally we deal with hard drive, either is HDD hard drive lah. Either is a solid state SSD or SATA, SATA or SAS. Okay, so SAS will be better than SATA, and solid state is more expensive because very fast. Okay, and because they are very fast compared to normal hard drive, right? So the solid state will be more expensive in that case. So depend on your requirement as well, what you choose. Okay, and when you use the like administrator, then we play with storage, then we play with RAID, RAID lah. So RAID, RAID can be RAID 1, RAID 0. 0 mean no, nothing. RAID 1 mean mirror. RAID 3, you have partition across different hard disks. You have RAID 5 also, and RAID 10, and so on. So they have many configuration. You go and see your own. And basically, the RAID is for if one hard disk fail, you can have a backup, another hard disk, you can get your data there. So in the virtualization world, some you can control the rate on if your subscribe infrastructure as a services, you can subscribe the whole storage. Okay, the other one option is actually using the snapshot, okay, to do the backup. Okay, so you can detach a volume, for instance, and attach to a different one. Okay, instant you detach with this one, and then instant, then all instant with the abstraction of micro instant, you have instant store, and this is storage that doesn't perceive. If the instant is stopped or terminated, instant store is an option for inexpensive temporary storage. You can use instant store volume if you don't require data persistence. Okay, so because like you create a virtual machine, okay, they have a basic storage for that, mean instant store, but most of the time it's not enough lah. So you require to maybe to buy extra EBS volume to mount it to your virtual machine lah. So Amazon S3 is a storage for internet. It provides simple web services interface that enable to store and retrieve any amount of data anywhere from the web. So if you want to create a simple web page, you can use S3 lah, static page. Okay, so the following figure show the relationship between this storage option and your instant. Okay, Amazon elastic file system. Okay, instant one, instant boot, and then host computer elastic blocks, EBS, and then you have S3 to keep your snapshot or bucket. Okay, so again, see back this one. EBS stand for elastic block store. Okay, S3 stand for simple storage service, and you have another one is EFS, elastic file system, if I'm not mistaken. Okay, so Amazon Cloud S3 functionality, you can write, read, delete object containing from 1 to 5 terabyte of data each. Okay, the number of objects you can store is unlimited, and each object is stored in a bucket and retrieved through a unique developer assigned key. Okay, a bucket can be stored in one of several regions. You can choose a region and optimize for latency, minimize cost, or address regulatory requirement. Regulatory requirement mean from the government, sometimes they have specific rules certain data they cannot move out from the country. Even you have data center, the data center need to be in that country. Okay, so you can have certain requirement to suit it or not. Okay, objects stored in a region never leave the region unless you transfer from out. Okay, for example, objects stored in EU region never leave the EU. Authentication mechanisms are provided to ensure the data is kept secure from unauthorized access. Object can be made private or public, and right can be granted for specific user. Okay, so these are S3. So example, S3 can store a wide content from web application to media file. User can offload entire storage onto the cloud. For example, your web page and so on, you can keep it using S3. Okay. Storage for data analysis, whether a user is storing pharmaceutical data for analysis or financial data for computation. Amazon S3 can be used to store the original content. Okay, the user can then send this content to Amazon EC2 for computation. Okay, without incurring any data transfer charge for moving data between the service. For example, you could stream terabyte of data of a genomic sequencer and store the final data set as a single object and then analyze any subset. So when they charge you, they also have certain charging policy. So if you move out to your whatever you keep in your EC2 or in your data center, you move out only the charge. Within the resources in the data center, they don't charge usually. They got outbound data they charge. Okay. So backup, archiving, and disaster recovery. So it offer a solution for you to backup. Okay, another one is Amazon Cloud Database. So what's done now? 7. Hold on. I on the light. Okay, so the Amazon Cloud Database is another type of service. The one is storage, and then now we go to data. When we go to databases, actually we move from the infrastructure to the platform. Okay, database are at the platform layer. Okay, if the application running on EC2 needs a database, a common way to implement the database for using the Amazon RDS, Relational Database Service, or launch an instance of database AMI and use the EC2 instance as the database. Okay, some you create a virtual machine. The virtual machine come with the whole thing already come with the database AMI because people are configured it already, pre-configured everything. So you directly get the image there. Okay, so when you directly get the image there as this one is still infrastructure. It's not a platform because you get the level from EC2. You still need to manage, even though the image already configured for you, but they're not going to manage your database. The Amazon AWS not going to manage your database. Why? Because they sell you only through EC2. Then, but the EC2 got the database image. That's all. Mean either you remember you have two ways. One way is you get the raw image of OS, and then you do it yourself. You run the bootstrap script, you install other service needed, like go and load the download the database image, the file, and then you install it yourself, and then it become a database server. So if you do it yourself, is you are doing at the infrastructure layer because you manage the database yourself. If you want the Amazon to manage the database for you, you directly subscribe to their database service and not using the image, okay, using the EC2. Amazon RDS offer advantage of handling management such as this one, okay. So what problem will come out? Regulatory issue, registry, job politics, security, application, hardware, blah, blah, blah. So these are, maybe if you are doing public cloud and so on, sometimes you need to look into certain issues lah. Okay, so I'm not going into detail. So when for example they do some survey on the rate the benefit that for the cloud and so on, so people will say because it's easy, very fast to deploy. Some agree on play only for what they use. So these are for example 1, 2, 3, 4, 5, 6, 7 top 7 they feel it is the benefits of cloud from sharing towards easy to deploy okay. But the top 3 are low monthly payment, pay only for what you use, and easy to deploy, okay. And the organize shifting fast in cloud use, current and future level use of cloud service in your organization, okay. So are you going to use cloud? When they ask, or are you now using, or are you going to use in future? So these are quite some time already, 2008. Now the percentage I think is reached maybe even higher, more than 50% already, easily more than 50%. These are 2008. You see, already future is around 30 to 40%, okay, and they are about 25% are using already, okay. At the current stage, I think more 50% to 60%, okay, at least they are using already, okay, and they intend to use more, okay. Sometimes due to many conditions why some people not choosing using cloud yet. Maybe their demand is very little, okay, and they are not serve worldwide customer. Their customer very localized, and then with their existing IT infrastructure is much more than enough, okay, and their IT need is not so high, so they are not even bothered to move to cloud, okay. So some are this one, and the other one maybe due to the competency of the old staff some are not trained for cloud, using cloud, so the existing staff are not confident or are not competent or not comfortable of moving their old application toward cloud. So there are many issues also why some are not yet moved and cost also is an example. Even though a lot of people say saving cost, but not really saving cost if you know how to manage well everything and so on. You might optimize them at your own level Let's say if you buy one PC can solve everything, and then you just subscribe to how to say, like internet service provider, and one IP, you have one public IP, then you can do everything already on the cloud. You don't need any cloud resources if you know everything yourself. You know you are a good administrator, you know how to manage your hardware well, and so on. Of course the cheapest is everything owned by you, and then you can do it yourself, one person, okay. But in real life is not. You need to employ people to manage for you. You need administrator, you need, and so on. So in that sense cloud is still a good option. But let's say you are computer science student, you want to start out your own business, create a cloud application, so the cheapest for you is actually everything do by yourself, okay. So these are is a fact. So you must not mean if everything cloud mean cheaper, then you also write cheaper. And you must calculate the cost yourself, okay? Because you do need to employ administrator. You are become administrator, okay? And electricity, you use your house electricity, maybe home usage is not very expensive, and you have only one server. You don't need aircon room, okay? So all these you need to calculate lah. When to use cloud service now, non-sensitive binary object like doc, PDF, use S3, okay? Moving server hosting to cloud, business case need developing, management tools not matured, not ready for enterprise apps, but soon, okay? Azure will be a key player for platform as a services, okay? For example, Google, Salesforce, main competitors, and lot of niche. Okay, and software as a service, when setting up new business, use it now. Don't saddle your business with expensive, inflexible asset you don't need. So if for those that, especially not in IT business, they are doing manufacturer, they are doing selling consumer things and so on. Directly use the e-commerce on the web, on the cloud. Don't need to set up your own. Ask people to build website for you. Buy one PC and so on. And later on, nobody maintain for you. And then your thing will be duplicating, mean obsolete, out of date. Nobody patch your thing and so on. So it's a very difficult. Okay, so for the business owner, okay, those that are really IT person, better set up a new business using cloud services. Okay, this is not in the perspective of programmer like us or whatever, in the perspective of business owner. Okay, okay, so these are finished. So we have 15 minutes. We still have time. So we go for the second topic. So any question? If not, we continue because public holiday we are already missed certain class. So we are chasing now. Okay, so can I continue with cloud architecture? Okay, class. Okay, so how many of you now? Participant. See participant. Are you all taking your more? Chat. How can I see participant? Oh, here. Okay, 9%. Okay, almost all are here lah. Okay, remember, take your attendance, and later we are going to, if we still got time, we're doing presentation later. I'll give you certain break. Okay, your first assignment presentation. If not, we can continue next week after the test. Okay, outline. Present cloud service architecture or cloud computing architecture and so on. So the test up to cloud service model. This one not into the test, okay? Architecture not. At least up to the cloud service model, okay? Up to just now, okay? Here don't need, okay? But related, okay? If you know, then it's better for your understanding, okay? But actually very short, only cloud architecture. Same like here we have infrastructure platform and software as a services, but you can see them in a diagram form. So for example, this is example of cloud service architecture today. They have, for example, on your left hand side, they have communication services, what to use. productivity services, and software development services, government services, financial services, real estate services, and so on. So there are different pocket of services. Communication means common, everyone use it. Okay, it's a quite common one. Sometimes we call it horizontal service, horizontal service. Productivity service also common, but sometimes it's more like a platform, more like a platform to support you to build your higher level application. Okay, like workflow, you have workflow and so on. Then you can build something using workflow also. Okay, and the software development services, this also platform as a services, okay, like IDE, database, and so on. Okay, and the government service, financial, these are called vertical service. Different business have their different vertical service. Some are doing manufacturer, some are doing financial, some are doing real estate, some are doing legal, and so on. So these are across different business owner have their different business services. Okay, so for example, cloud provider also have different continent. One are more close to the user perspective, one are more close to the system admin and ops. Close to system admin is called supplier ecosystem, like infrastructure as a service. Close to the developer or user, then more to a platform as a services. Okay, so cloud technology reference model. So we can see a certain kind of common. Why I put here reference model mean because, for example, we can study only AWS, for example. And then from there, AWS, we take out each layer. But it's not fair because AWS is only one example from Amazon. Amazon become a very pioneer and popular, like de facto standard. A lot of people use it, but there are many more. Okay, they can be, for example, cloud service provider from Alibaba, from Huawei, from Microsoft, from Google. So can we have a more neutral model for us to refer to? Here is the objective of the class. This class, we have certain more how to say generalized or abstract rather than I give a name. Okay, so you in reference model, at least at the infrastructure we need to manage an element. Okay, each element can be hardware, software, or network, and so on. Then we can manage resources, mean who need this resource, who how much they want to reserve, and so on. So it how to say, it goes to each other. For example, virtual machine. How to configure your virtual machine? That element. How many virtual machine you require? How big at the virtual machine you need? Then you consider as a resource. Even though they are both machine CPU, but you look at different angle. Okay. So facility, logistic, software, hardware, and testing, monitoring, diagnostic. Okay. So a web of metadata, what use or contain what other things. Okay. So metadata mean, what mean metadata? Metadata mean the data that describe other data. Is called meta. I mean, for example, metadata of database. What is metadata of database mean? How your table look like. Your table consists of how many attribute. Each attribute, what are the data type of the attribute? These are called metadata because the data describe your table. Okay, and then when the user keep in database, what they see, they didn't see metadata. They see only what? They see table called student, and then got student name, got student ID, got student marks. So they see only like for example, student name Chan Hua Yong. What is the marks? They didn't see metadata. Student table consists of 10 attributes. Each attribute is what data type. Okay, that is metadata. Okay, so same the metadata for cloud and so on, you need to define how the cloud service need to provide to user, right? This cloud service own how many resources. So you need to define all this in your, as a service provider, I need to keep all this information so that I can provide them, I can serve many different type of customer. Okay, so I need to keep all this configuration in my repository lah, in my website lah. Okay, so web of metadata. Okay, and life cycle, when and how can things change? Okay, so sometimes your resources, you stop them, you restart, and then you migrate. Okay, so all these status need to be recorded down lah. So the status of your resources need to be recorded down. We call it life cycle lah. It's like human being lah, or the animal or the living object. All the living objects, we call it object lah. Living objects have a life cycle. So now we treat the computer system, the program, because the program can become a living object. What I mean living object in computer term is when you download it as an image, when you download it as an image, this image is not execute at all. Okay, it's not on live. But when you bring it, execute it, like we start, initiate or start, when you start it, it become birth, it become on live. The object, the date object is called file or image. The live on the object there on live is called instance. So when it on live, it got live living object, it's called instant, and this instant called birth lah. And then the instant, if you subscribe more and more instant, or you make your instant more, then your thing are growing. Okay, and for example, your instant of database can grow from initially you keep only 10 records, then your business growing, then your database object now can keep 10,000 records or 1 million records. Then your database object growing. Okay, and then for example, certain file corrupted, and then it cannot work, then failure, then you need to get corrupted file from somewhere else, then you call recovery. Okay, and you, for example, this database you don't need anymore because you build a new database that you migrate you copy all the data to new database. Then the old database you don't need anymore. Then you delete the database. Then it will die, death. So these are also the thing that you need to manage on your cloud, the status of the resources and so on the cloud, that the object is living or put aside or sleeping or pause, or you stop it. Okay, a cloud technology, and then the governance view and architecture views. So governance views are more towards the administrator because the security level also split in the cloud. A good cloud model, for example, AWS, it's not security is maintained by AWS. No, the security actually maintained by the practitioner. The AWS just provide you basic services like the machine. They want to ensure the machine always up. If you subscribe to them, they have 0.99% or 99.99% always available or whatever, or 99.9999. How many nine behind? is a service level agreement. They need to ensure that this thing up. Okay, but whether who can access your file, who can read your file, who can write your file, who have read-write permission, who have executable permission, is you define. It's not AWS define. So this called split responsibility. The split responsibility let you define your own authorization. Who can authorize to execute, who authorized to read, and so on. Then who can do what. So these are called governance. Okay, so security module, at least they are security module there. Okay, and architecture view, how my concern address in terms of scalability, availability, recovery, quality, and so on. So architectural view are addressed in the contract that you are doing with the service provider. Okay, and the contract, the more secure or the more scalable or more available, then you need to pay more and you are more concerned on recovery, then you need to subscribe to backup or whatever, then and so on, then you need to have better services subscribe to better services, either you pay more or what, or you choose among the uh, cloud service provider which give you better service, then you choose them. Okay, so these are, for example, by layer approach, you can see them. You need to this one. So their problem in a cloud service provider problem. Your problem, you maintain your problem. So it's split between the two. Who responsible for what? Okay. So these are cloud server, infra, and then your problem. Okay, so if you have your own administrator, okay, then the cloud server part can take care by your administrator by your own administrator, your own administrator. Okay, then you just handle the development, or you are end user, so you just border your application only. Okay, the rest are you have your company administrator. Okay, and that's the thing. But if, for example, you don't have your company administrator, system administrator, then you advise is you use a platform as a services, then you define your governance and so on at application level. Okay, at application level you can define the governance. Okay, and then the rest are handled by administrator, public cloud administrator that provide you platform as a services. Okay, cloud platform as perceived today, you just highlight what who can do what, and then your application, you put your application, then voila, it's worked. Okay, so these are, and how cloud platform likely will evolve is you put your governance application, and then sometimes you need to split responsibility between lifecycle and architecture. Okay, you can define what kind of service level agreement you like to have. Okay, you can define, or how scalability is. That's why come in like infrastructure as a code. Okay, you can say I want to scale, how I'm going to scale my application. I want to define my own architecture there, how many instance I need, and so on. So that can be done as well. Okay, fill in the architecture gap. So architecture aware, one lifecycle element, and so on. So these are certain trend that people do research to fill in. And now actually this gap also already fill in. So you can use a certain thing, like I say, like infrastructure as a code, and so on to do this kind of thing. Okay, so enabling technology for cloud computing architecture like service-oriented architecture or virtualization technology lah. These are enabling technology I mentioned before lah. These are my previous topic on the virtualization that day. And service-oriented architecture, I think in a very early topic that we talked about distributed service, what is parallel and distributed processing, and service oriented architecture is basically you provide very high application, and then you use them instead of as a GUI or as a user interface, you as a application programming interface allow people to call them lah. And last time there are many ways to call them, like using socket, using remote method invocation, and so on. And nowadays people are moving to web services lah. Web services like SOAP or REST. REST are become popular. REST protocol, REST. Then you can access to the web page by and then see the XML code, for example. Then you send the XML code, you get the XML code as a result. Send XML code as a parameter, or using the put get this kind of thing lah. Put get. What else? Put get. This one HTTP put HTTP get, and so on to get your result. Okay. Cloud open architecture 7 principles. Okay, you need 7 principles: integrated ecosystem, management for cloud, virtualization for cloud infrastructure, service orientation for common reusable services, and extensible provisioning and subscription for cloud, configurable enablement of cloud offering, unified information representation and exchange framework, cloud quality and governance. Okay, these are called open architecture. Mean what? Open architecture, sometimes you don't want if for example you are but in the business environment, usually they will choose the market leader, and then this market leader are very popular, and then they are trust around that market, feel that they can be trusted. Then many people are subscribed to their service. They're willing to pay more because they are choosing the market leader, and then they trust them. Then the industry people will subscribe to their services. This is one of the common way people use it. But sometimes it's good to have open architecture. You promise to have open architecture so that the customer won't lock themselves into one particular vendor, and then they discover the vendor is not good, and then they want to change, they want to move around to other vendors. They are locked because the thing that they provide is not open. Okay, they close it and so on, and then close architecture there for user is everything is like black box. They just pay and then they just get, but there's no common standard between each architecture. So here is try to address the issue of, is there any guideline if you are a cloud service provider? Do you have a certain kind of services that are common? Every cloud service provider, whether you are Amazon, Microsoft, or Google, and so on, you need to have certain kind of common thing that end user can rely on. So these are called the principles lah. Okay, so you can see 1, 2, 3, 4 from just now, and then go to here. Okay, the one is the basically is the cloud ecosystem, cloud client dashboard, either cloud vendor dashboard or cloud partner dashboard, mean at the user interface side from the your software. You build the GUI, okay, dashboard for your partner, for vendor, for client, okay, and then from there you go into the infrastructure management. Can the user manage the infrastructure through the web GUI and so on to manage each element or resources? Okay, and then you go to third layer. When your business, I say, can be horizontal or vertical. Horizontal means quite common to different industry like CRM, ERP, enterprise resource planning, or customer relationship management. Then you like certain software vendors, they provide platform as a services like Force.com, Salesforce.com, and so on. So you use or the other one, popular one is called SAP, SAP, this kind of company lah. So you can use their program or their library. Then you don't need to write from scratch. You can make use of this library faster for you to build your application, business application. Okay. Then the layer 4, then you are user able to subscribe or not, and start, stop, provision. This is called the life cycle. Just now, for example, you see whether you can control all these roles and so on. And then level 5, cloud value added service or offering. Okay, as whether as a infrastructure and so on. Then you build your layer up incremental, and then very divide and conquer by layering it properly, and then with all the component you can control each other, or they are interdependent, yet they are one of the component now not affect others and so on. So these are the architecture lah. You have cloud information architecture on your right hand side, 6 and 7. You have cloud quality and governance. Okay, so from seven layer, okay, you have 7 principles lah. Okay, this diagram are actually talking about just now the 7 principles. Okay, infrastructure cloud, what is that? Business cloud, what's that? You can see more detail. Okay, so these are example service delivery model example. Amazon, Google Apps Engine, platform as a services, and Windows Azure or Force.com, okay, and Salesforce.com. Okay, I think the Force.com and Salesforce is same company, right? They look similar. I'm not sure lah, but look like from same company, like Google Apps and Google Apps Engine. Okay, so cloud ecosystem. These are another example on the instant. You can have virtualization using CERN, KVM, VMware. Okay, and then you have the BI management, Open Nebula, cloud management. Then you have cloud consumer. Okay, so these are a bit small. I'm not going there. You can look into this in detail. The impact on ecosystem, okay, infrastructure, I think this one maybe covered before, I'm not sure. The infrastructure as a services vendor, transparent to user. Okay, if for example, you just see virtual machine, you didn't see, is it from Dell, or is it from OEM, or is it from different vendor, IBM or whatever. You didn't see their machine name because you subscribe to how many CPU you want, how many memory. So everything become virtualization. Okay, so virtualize. Okay, and platform as a services, common middleware, value added, open source, big company dominate, giant marketplace. Okay, actually, if you want to be doing business in IaaS and PaaS, you have to be a global player, like like Yahoo, like Google, like Amazon, like Microsoft, like Huawei or Alibaba. Okay, so need to be a very big company and then present in the global market. Okay, the application as a services or software as a services then is mushrooming because you don't need so big capital, but you can also go growing to global market or region first, local to region to global very fast, because the more people use it, you can able you afford to subscribe more because you got more revenue, and then you can easily grow because you don't need to bother about the infrastructure, you don't need to bother about platform, you go directly put your application only, then your application subscribe to all these cloud platform, they can scale because we say elasticity, right? You can scale up according to your load, according to number of customer that use your system, according to the workload. So then it become very fast for you to grow, make present in the global market as well. So and then your capital is much more less. You don't need a very high capital. For those IaaS and PaaS, IaaS need more very substantial capital, very huge capital. PaaS need less. AAS very fast. Anyone like now, if you graduate already as a master's student, you can directly write your software as a services, and then you directly can conquer the IT market. Okay, issues with current cloud user are often tied with one cloud provider. Computing component are tightly coupled. Okay, and lack of system level agreement support, lack of multi-tenancy support, and lack of flexibility of user interface. These are certain current problem lah. Solution service-oriented cloud computing architecture support easy application migration from one cloud to another and promote an open platform with which open standards. Okay, so another one is service-oriented cloud computing lah. You use a basic API, and then you move around your if you can move to different vendors as long as your API, the basic API won't change. Okay, if change also, you can do it quickly by modifying your because you have like service provider, producer, or service consumer. So if you consume certain service and the API of provider change, then you just change accordingly in your apps. Okay, then it still can work. Okay, so these are things like concern on this one. So how to work on this one? You have registry, service agent, and so on, broker, consumer-centric, service-oriented architecture. So what is consumer? These are diagram. You have the broker, then you aware where the service reside. Then when you call the service, you ask a broker will give you the endpoint. Okay. So an application builder develop an application template. The application template register, provider subscribe to the application registry. Automatic matching between requested and registered application template. Find an application template, submit it to an application template. Service broker will notify the application builder. Builder test and evaluate the service into target application. So these are more towards how you build a cloud application using certain IDE or framework, using certain framework, and then this framework use a template. Okay, template, and then you put your code inside, then it can discover with the registry, with the broker. Okay, so say next time you can build your application which is called global software and enterprise. Your application can call any service around the world, and that you can become bigger and bigger. Okay, so when you call the service around the world, actually you make use of the platform as a services very well, and then actually the software as a services, they can go one level down and not give you only API, GUI. I can give you API as well. So example, like let's say I build a code with how to say, with only GUI, then I need to call the code. For example, let's say I Google, then this one, the web is actually give you in terms of URL. So they have URL, and then they can give you certain kind of either HTML or XML. So actually on the web, actually reside concept called web services already. For example, I not simply get the application, not simply get the text base, but I can actually key in parameter and become a how to say, become application on the web. For example, let's say I say dollar versus ringgit. I want to know the rate of dollar between these two. So I say let's say $5. How much? 15 for example, $15 US dollar. I know it's equivalent to 65 ringgit. Okay, 65.84 ringgit. For me, this is like money exchange calculator. So it's a service, it's no longer a normal text. Okay, for example, I want to see, let's say I want to see Maybank, let's say Maybank. I want to see Maybank share price. Okay, then here for me, it become an application. It's not only web. So I can click, for example, maximum what is the maximum for this? What is the 5 years? So I can interact with my browser. Yeah, how this can be achieved, because it's not only give you GUI, behind it using API to call these particular services, either from Google or from Yahoo or from anywhere. Okay, so actually now the browser is, you can call this already is a global software enterprise. Mean your things is global, you can call anywhere, any place. So you can build something like this, then these are something of the future lah. Okay, when you build application, not everything built by your own, build your own only and so on. You can make use of other people software already there, and you can use that chart, you can use that thing, and then you can call them. For example, just now you need the foreign exchange rate. You didn't need to write your own program. You just call the web services, and then you get the current foreign exchange rate and so on. And for example, the chart, you can get the chart from what trading view or from what and so on. Some they give you free API. However, they only support up to certain data set only lah, because free one, of course, got limited features. Okay, so these are example of core software-oriented architecture. Okay, so scientists direct access to Nebula cloud computing. Okay, for example, just now I use browser. So if I not want to use browser, I want to build my GUI, I can exactly call the chart out and so on, because the browser already call using web services. So I can do that exactly, and can then put that in the right window, or the right, using a different color, I can do that. Okay, so these are the beauty of calling other people. Another one, you know, the Nebula. These are example of another one is called NASA. You know, NASA sending the satellite, sending the this one on outer space. So how they collect the data, how they do this. This is another example of their own private cloud. So the NASA private cloud, the example are this one. Okay. So how they do cloud computing using their machine supercomputer, and then they run what kind of simulation on that, and then they keep it in their storage. Okay, so these are, and then they call it nebula lah. Nebula is the word, and then they whatever resources they put in container, you can see. Okay, the resources. So these are example of one of the example of they are using a cloud computing architecture. They come out their own cloud, but these are their open and public API, but they are built their private cloud. Okay, and then they let other people to access it. Okay, they build their own private cloud because they got fund from the government, and then they build their own resources and so on. But yet people can use their API and they can access to the data they keep. Okay, so how they do this one, because different scientists, they require different compute power, and then they use also cloud node to execute their things. Okay, and LDAP is a lightweight directory access protocol. It's just a lightweight database to keep data. It can use for authentication and use for authorization and authentication. Okay, can use for security as well. This kind of thing lah. Compute node, okay, running virtualization KVM or library of virtualization, and then running instant, and then using virtual LAN, VLAN, and then volume they can export. Okay, and then they can use the Nginx instant, run on Ubuntu and so on, object node. These are example lah, example. So we finish it the second part very fast, because this one is we have two how to say we have basically two lecture that we missed. One on the one public holiday is for the Raya, and one for Visa Day. So actually this week supposed to be semester break, no lecture. So I cover these two lecture here, and then because we are public holiday last time, so I use this one to chase back whatever. So our test will be until the cloud service model, the architecture, the NASA one is not inside the topic now. The second one is not inside the topic until cloud service model. Okay, and basically I finished cloud service model and cloud architecture. Then now, because we have still got time, so we call for maybe break for me, 15 minutes break. Okay, we around 15 minutes, we come out at 8:15. Then we start presentation of your assignment, and then we see we can finish it or not. It cannot finish, we continue next week lah. So until 9 o'clock lah. Okay, we come back at 8:15. Okay, any question? If okay, give me one. Okay, remember to submit through e-learning. Those that not ready, maybe it's okay. Next week we can continue. Okay, please present first, then you don't worry about your assignment already. You can focus on your on your task. Okay, so see you.
Hello, doctor. Can you see?
Yes, please proceed.
Hello.
Yes, please proceed.
Okay. Thank you, doctor. So, good evening, everyone. Today, I'm going to do a short presentation on comparison of Amazon and Google Cloud Computing platform. So, I'm going to start with the introduction, generically on the cloud platform. So, cloud computing is a service which is widely used across the globe by 90% of the human population. So basically, what is cloud is that uh, cloud contains data which is accessed regardless to the location, as long as users have access to the internet connection with a minimal subscription fee, depending on the services that they require. And also, cloud computing is made up of three tiers, which with with other cloud clients, such as hardware and software. So the three tiers, first is the infrastructure as a service, second is the platform as a service, third one is the software as a service. So more detail on the tiers of cloud computing is that, uh, for the software side, so on the infrastructure side, sorry, on the setup is on the premise data center. So on the setup is basically including
Can you put
servers.
on the presentation mode bigger your
Okay,
screen?
just a second, doctor. Let me change screen because I'm using multiple screens, so it's a bit.
It's okay, that's okay.
Is it okay now, doctor?
Great, great, great.
Okay. So starting with the infrastructure, so it's basically set up on the data center, which includes the server storage and high-speed internet connection. It is considered as to a more personal kind of setup depending on the user requirement. So this setup is mostly used as a backup storage. Secondly is the platform as a service. This creates and maintains a stable and optimal environment for the users to deploy apps and data sets. So users can focus on developing and executing apps rather than building and managing infrastructure and services that support them. So this basically creates an environment, something like a Linux environment, for an example, uh, in a remote setup. So users can basically run uh, an application which requires a high hardware computing specification on a remote setup. So that's one. Then the second one is the software as a service. With this one is to reduce the requirement for business to install and run software on their own servers or data centers. Users subscribe rather than purchasing a certain software. For example, users can use like a high quality video editing, or maybe a user want to build a machine learning model which requires a high computing speed. Users can utilize this kind of cloud computing. So moving on to the next slide. So based on the research, okay, based on the research that I've done between two cloud computing, is that the Amazon cloud and also the Google cloud. So basically, the Amazon cloud contains the application services, the database services, big data analytics, and also to mention that the enterprise application, IoT, mobile services, and game development. So here I've highlighted green in the list. It's because these particular services are only found majorly on Amazon Cloud. So I did not manage to find more information on the four, which is the enterprise, IoT, mobile, and also the game development services on the Google Cloud. For the Google Cloud services, we have compute, storage, and delivery content, networking, and also machine learning. So for the machine learning, also similar, which I managed to find on Google, the particular service on Google Cloud, but not on the Amazon Cloud. So due to time constraint, I'm not going to explain too deep into the comparison. Let me move on to the next slide. Based on the comparison, I also found others two services which has similar reliability for both cloud platforms, which has like a similar number of use cases, which is the security and identity and also the developer tools. Moving on. So, as a conclusion, based on the research that I've carried on, Amazon and Google's cloud platforms were compared in terms of the categories, services, and also the cost per virtual machine instance. So, based on my findings, Amazon Cloud is reliable since it has a very large variety of service categories compared to Google Cloud computing platforms. For for lower pricing, users can consider Google Cloud based on their cloud service requirement. As compared to Amazon Cloud, Google Cloud setup is quite cheaper. Thank you.
Thank you. Any question from the peers? Any question from the classmates? Ask anything regarding this? Have you tried out your own the AWS
For me,
or the Google Cloud? Did you look at the have you tried the tutorial or something or see the tutorial from the Google from the YouTube or what?
I've tried the once last time I tried programming the Firebase cloud. Excuse me, Doctor. Okay, last time used to program a Firebase cloud for a project. So basically, to read uh, sensors, like using a sensor, it reads the data and it uploads the cloud. And based from the cloud, we managed to reflect it to to our mobile phone, like a smartphone, through an application. Hello, doctor, you are muted.
For the Firebase is on the Google or on Amazon?
I think on Google. Yes, on Google. On Google.
So how cheaper is the Google Cloud compared to Amazon Cloud?
Okay. For the Firebase, that the version that we use, it was free. It was open source. So there were some limitations. So we did not really buy the.
For your last conclusion, you said for lower pricing. Can you give example?
Lower price. Doctor, let me refer to my. Uh, for example, like services, right, doctor?
Yeah.
Okay, let me.
No. For example, the price. You say
Oh,
lower pricing.
oh, the pricing. Okay. Um,
Why you say that? So that my question is how cheaper is cheaper?
uh, it depends, doctor, because certain it depends on the functionalities because certain Amazon is majorly on the computing side, so that if we consider on the computing side, that may be the reason for the Amazon to be pricier. So Google Cloud is mostly on the data access, and the computing side is not really reliable on the Google Cloud. So that's the reason why it's cheaper.
Oh, okay. I didn't quite understand the kind of logic, because for me is when you compare say cheaper higher, maybe you say virtual machine, this one cost how much, that one cost how much, or the database on Google Firebase or whatever cost how much, the other cost how much. Because sometimes you can only compare apple to apple, orange to orange, but they still can compare, right?
Mm,
Because
mm,
they
mm.
have some similar services, right?
Yes, understood.
Okay. So I think thank you. That's all.
So doctor, another thing, right? So can I still modify my technical paper
Yeah,
before
I give it I give it until uh 00 hour.
Okay.
You all want to extend it? I give it tomorrow 00 hour. I think 00 hour very soon, right? You want to extend it? I can modify. Can you stop
Okay,
sharing?
okay, doctor. Thank you.
Uh, e-learning. I maybe I prolong a bit. Seven submitted. Hey, time remaining 3 hours only. I prolong it a bit. I give you one more day. So you have an extra 24 hours. Okay, 1 day, 3 hours. Okay. So you have 1 day, 3 hours for you to modify. Okay, next. Bayuk, Hamza, are you ready?
Hi, Professor. Yes, I'm ready.
Okay.
Just second to share my screen. Okay, can you see my screen?
Yes, please proceed. Yes.
Okay. So, I will make a conversion of two NoSQL database system. Because of rapid increase of data sources nowadays, produce a huge data that needs to be managed. More data is being collected and more users are accessing this data concurrently.
You use presentation mode.
So, sorry?
Can you use presentation mode? Make it full screen. Your PowerPoint. Okay, thank you.
Okay. So today, companies and business owners need to manage large data volumes at high speeds with the ability to scale up quickly to run modern web application in nearly every industry. In this era of growth within cloud, big data, and mobile and web applications, we must know which the best database system for us to store and deal with our data. So In 1909 and 2009, a new generation of database system started when NoSQL database appeared. NoSQL referred to as not only SQL or non-SQL. That's database design, storage, and querying of data outside the traditional structure found in relational database. So NQL, NoSQL database house data with
Your presentation around 10 minutes. How many slides you have?
13 or 14.
So you go less than 1 minute per slide because maximum is only 10 minutes.
Yes.
Okay.
Okay. Okay. So NoSQL database house data within one data structure, such as JSON document. Since this non-relational database design does not require a schema, it offers rapid scalability to manage large and typically unstructured data sets. Sorry. So there are many NoSQL examples such as MongoDB, Apache CouchDB, and Apache Cassandra DB. Each foundation claimed that their database management system are better than the others. So we will compare now MongoDB and Apache Cassandra database. So MongoDB is an open source and a leading NoSQL database. It's a document database built for general purpose usage. It stores data in optimized JSON format called BSON, like a binary JSON. This allows the MongoDB document model to benefit from the flexibility of JSON documents stored in logical groups called collections. So now Apache Cassandra is a free open source NoSQL database. It implements a columnar storage architecture and can handle large volumes of data distributed across multiple Apache Cassandra nodes. Every node in Apache Cassandra is able to perform read and write operation. Because of this, data can be replicated across multiple nodes to provide availability in case of node failure. If a node failure occurs, the user is redirected to the nearest available node having the required data. So Apache Cassandra does not have a single point of failure and can thus provide high data availability. Now, the factors that lead to Apache Cassandra with MongoDB decision. First, data model. Apache Cassandra implement a columnar storage architecture and store data in the form of traditional rows and columns. On the other hand, MongoDB data modeling is done through its document data model that are stored in binary JSON. So if the data you are trying to store has a fixed format that's not expected to change much, Apache Cassandra would be suitable for you. But if your requirements include more dynamic data that does not have a predefined structure, so MongoDB would be more suitable. Now, about the availability, MongoDB has a single master directing multiple slave node. If the master node goes down, one of the slaves node take over its role. So also that strategy of automatic failover does ensure recovery, but it may take up to a minute for slave to become the master. During this time, database isn't able to respond to requests. Cassandra used a different model. Instead of having one master node, it utilized multiple masters inside the cluster. With multiple master, there is no fear of any downtime. So if your business and data requirements need 100% data availability, Apache Cassandra would be more suitable. But if some small amount of downtime can be tolerated without major repercussions, MongoDB would be suitable. Now about scalability, distributed database only allow master node to perform write operation. So in MongoDB, with a single master node, it can only perform one write operation at a time, hence can be considered to be limited in terms of writing scalability. On the other hand, Apache Cassandra having multiple master node can coordinate multiple write operations at the same times. Programming language, MongoDB supported by C, C++, and C# and Python and so on. Programming language supported by Apache Cassandra are Java, JavaScript, and Python, and PHP, and so on. So the final decision depends on the programming language the application of your business are written in or will be written in. Query language, Apache Cassandra support a query language called CQL, whereas MongoDB does not have a support for any query language and can only structure queries in JSON formats. You can see the example here of a CQL language, and here the MongoDB JSON file. Now in the pricing, Apache Cassandra is a free for all users. Just the user only have to pay for the data warehouse that will be used to store the data. So the final pricing for Apache Cassandra depends on the data warehousing solution being used by the business. On the other hand, MongoDB offers 3 pricing plans based on the business requirement. And these 3 plans is the first one, cloud database as a service. This plan offers a cloud data storage solution fully managed by MongoDB, and it have 3 offers. The first one shared clusters, and the second one dedicated cluster, and the third one dedicated multi-region cluster. And this is the prices for him from the Mongo website. Okay. This is the second type, on-premises or private cloud solution. And the third one is MongoDB Realm. About the conclusion, choosing the right database is a big decision for any team, and one that should always center on the needs of the application now and what those needs will be in the future. So with that in mind, Cassandra and MongoDB can both be great options for inclusion in model. And thank you.
Okay, thank you, Tayyub, Hamza, for your presentation. Who provide Cassandra services? Who provide MongoDB?
Just a second.
No, can you hear me?
Yes, Professor. Sorry. Okay.
My question: Who provide this service on the cloud? In terms of Cassandra and in terms of MongoDB. When you say the price, who provide service of MongoDB on the cloud? Amazon or Google or Microsoft, or when you say the price?
The price I see in the MongoDB website.
Yeah, from who?
Oh, I think from Amazon. For MongoDB from Amazon. Cassandra.
Because there are different vendor.
Sorry?
Okay, there are different vendor give different price. Okay, the how about the Cassandra?
Who provide the price?
Who provide the service of Cassandra on the cloud when you refer to Cassandra?
Apache Cassandra, Google Cloud.
You know, there are many vendors provide database service.
Yes.
Anyone can provide. You also can provide Apache Cassandra. You can provide MongoDB. You depend on the vendor.
Oh,
Okay.
okay.
So when you talk like that, you must have this perspective. It's not MongoDB from MongoDB vendor. Only one. Apache Cassandra from Apache Cassandra vendor. There's no shop called Apache Cassandra because it's open source. There's no shop vendor called Apache MongoDB. Understand?
Yeah. Of course.
So this one depend on the services. For example, Astra also provide Cassandra. They have different model. Not necessarily mean data warehouse only they are free. Astra, you go to Astra website, Cassandra, they will provide with different pricing charges, with different charges. Okay.
Okay. That means
Depend on how many peer you are using, how
yes.
many clusters instance you are using, how many instance of cluster you are using.
That means each company or each one used Cassandra provide the price.
Yeah, of course.
Okay.
You can provide Cassandra also. Then you charge differently.
Okay.
Okay.
Okay, sir.
Then it's not called master, many master. In Cassandra, called peer. You use peer-to-peer concept. There's no master. Everyone is the same. So anyone down, there's no problem.
Yes, in Cassandra,
It's
no
not called
problem.
multiple master.
Not more than one master. It's
No, it's not
peer-to-peer.
called multiple master. It's not
Yes.
calling multiple master. It's called peer-to-peer.
Peer-to-peer. Yeah.
Yeah.
Okay.
Okay. In your
Okay. Okay.
presentation, you say multiple master. Okay.
Okay, sir.
So, and the other question is on the, let's say in the JSON format. Okay. For
Yes.
example, let's say you have a record called student. Okay.
Sir.
Then you can have student name, student ID,
Yes, sir.
student many all cannot. For those that cannot present, you don't need to say sorry to me because it's okay to present next week. For those that cannot make it, you can present next week. Okay.
Sorry?
No worry. For those that cannot present now, you can present next week. Okay. Those that can present today, present it. Okay. My question to Dayub, for example, you create a student record. So in Cassandra, you create a table called student. Then you have attribute student name, student ID, and so on. And then in JSON, you also insert a table called student, and so on. So for example, let's say you have 5 students. Okay, student 1, student 2 with different names and so on. In JSON, how you store it? You store it as one document or you still store it as 5 documents? Let's say you have five different students.
Yes.
Is it one document, one big document consists of all students, or each student have one document as a one document?
I think it's one document, not 5 documents.
One document that consists of all the different students. So when you insert, it keep on appending to the document.
Sorry?
So when you insert a new student, it
Yes.
keep on appending the records to the same document. Is it?
Yeah.
Your document will getting longer and longer.
Ah, so right.
Is it?
No. It's 5. I think it's 5. So
You better check. Then you give me answer after the next presentation. Okay? Now
okay.
you Google and tell me later.
Yes. Okay.
So you must, when you do something, when you study, you must go into that lah.
Right.
You cannot guess. Okay? You find the answer and then tell me later. So next, Ibrahim Abba, are you ready? Hello? Ibrahim, I cannot hear you. You are mute. Can you unmute? No, then we go for another one. Shiri or Adil, are you ready, Adil? Adil Awahibi.
Yeah,
Ibrahim, are you ready? Ibrahim?
yeah, sorry, the system is kind of slow, so I need to, there's a delay, but I will turn on the video now.
Can you present now?
Yeah, no problem. I'll present. I
10
have this
minutes
slide.
only, 10 minutes only. I think
Okay,
maybe after your presentation is the last. The rest I have to present next week. Maybe
Alright.
one more. So don't go too long.
Okay,
Because I will do Q&A also.
all right. Sorry, is the screen on?
Please share your screen. Share. Click share.
There is issue with the browser. I think the plugins. Let me allow.
You share your screen. We cannot see your screen. Did you click share?
Yes, I click on share.
But nothing come out.
Yeah, maybe it's
Then
coming
you
up.
wait. Maybe
Okay.
you wait. Adil, are you ready? Adil Al-Wahibi. Can you speak? We can't hear you. We can see you from video only. Video screen. Where's your screen?
I'm trying to
Ibrahim.
share. Yeah, I'm trying to share the screen. Sorry, let me stop the video.
Who want to present next? Please tell me who want to present next. Next is the last one. Then you need to present it during next week. Who want to present next? Adil, can you say something? Adil? Shri Chakrawati?
Hello, sir. Can you hear me?
Yes.
Okay.
Are you ready for the last presentation? Are you ready?
Not so, but I can give it a try.
Oh, you're humble.
Yeah, but
Because
no,
we are
actually,
waiting for Ibrahim to share. I think he got problem.
Yeah.
okay.
Then now you do first. Then Ibrahim will do later.
Okay, cool. I think I can yeah, do it
You
now.
can share, right?
Yep. So I just want to clarify. Are you all able to see my slide?
Yes, yes. Very
Okay.
good.
Okay, nice. So, yeah, before starting this presentation, I am totally new to the cloud domain. So, if as any errors, please do forgive me. But okay, then I would start it now without further ado. So, as based on my understanding, right, I personally feel that cloud is basically a memory storage. Mainly, in my understanding, I feel that it's a memory storage which is used to sort out huge data in sense of management wise, like for example social media data, anything, those all data. So based on the introduction, right, I could say that it's a computer approach that, hello, can you hear me?
Yes, yes.
Okay, so it's a computer approach
Go
that,
fast, go fast, then Q&A later.
yep,
Less
it's
than
a
10 minutes.
okay, it's a computer approach that enables comfortable on demand access to a set of computing resources. So in general we can say it as IaaS, PaaS, and of course the software service which is SaaS. Okay, so in the next slide would be now this one is just the research method which I compiled. So in this case we can say that many cloud computing services provider arise on international scale such as Alibaba and Microsoft Azure. So as it's in the context of big data service, we can say that IoT system is one of the continually gets device data at certain time and generates large amount of data. So as the results, IoT system requires big data services to handle this data. Okay, so currently evolving, those big data services are currently evolving into more complicated architecture in order to handle big data, as more users, more data, and so many sorts of accumulation occurs. Now the next is the cloud computing management. So it basically, why do we manage cloud computing? Because it allows various instances in the development of IoT applications. Okay, so the development requires one or more server of computers, either in the form of containers or virtual machine. So as the results, computing services often include at least the least management related service for users to establish, monitor, and govern the sessions basically. Okay, so previously talking about the data center location. So sorry, yeah, the data center, right? So each cloud computing services provides data center location in various places, but not all provide data center locations in every country. The location of the data center affects the network's latency basically. So there are two things to consider when choosing a cloud computing service. One is based on the location of the data center. If the system requires low latency, it's necessary to choose a data center location that is in the same country or the closest to the location, right? The second reason is it's about the strict policy of the local government basically, which must choose the location of the data center which is located in the same country as the device location or IoT system user that has been developed. Okay, so now, oops, sorry. So now the another part is I would march forward to the discussion part. Okay, so now basically now we are comparing Alibaba Cloud with Microsoft Azure, right? So it basically Alibaba offers a unique solution for IoT system called Alibaba Cloud for IoT platform. So this service provides low latency communication services between the IoT platform and user nodes, as well as the security services. Okay. Now this is actually to enhance the confidentiality of the data communication using different steps. So this is basically to for the security of those data which is being stored, right? So the ability of Alibaba Cloud platform is to service to link with other Alibaba cloud services or application interfaces systems previously built for the user's benefit. Okay, but on the other hand we can say that Microsoft Azure, right, it's offers numerous big data services packages that may be utilized in IoT system. So it's like Microsoft Azure is specialized service offered by Azure as cloud computing solution for the creation of IoT system. So we can say that user may connect to IoT device data supplied to the Azure server with the data analytics, or we can also have the machine learning system using this service. Okay, so now as in terms of comparison, it's like both of it is plus minus the same, but just that they have various services. So in the summary, it's like based on this summary table, right? Okay, so based on this summary table, what I can conclude is, as it's too much of data, so I mean too much of details. So in summary, I can say that all the cloud providers offer ample of computer resources. So we can say that all the providers basically they provide IaaS, PaaS, and of course the software service, which is the SaaS. So Azure and Alibaba both offer specialized cloud management such as microservices and dedicated services. Okay, but it's also said that the majority of them use Kubernetes to control infrastructure usage by distributing computing resources efficiently across microservices. But there were also certain sayings as which I came along this research. I found out that there are certain users have commented that the cost of Alibaba is cheaper than Microsoft Azure, but I don't know precisely what is the what they call that, the significance of the pricing. But it said that generally it's cost saving compared to Microsoft. But if performance wise, since Alibaba is new to the market, so it's like Microsoft has already has its base established, but can say that the next couple of years probably it could be comparable in terms of performance, just by this was users feedback from various research papers. Okay, but in conclusion, I would say that what's that based on the findings and analysis, right, several cloud computing providers are frequently used by developers. Okay, so as the result, based on the preceding statement, the parameters created in the study can be utilized as a reference for developers when they are designing an IoT and big data application, when they are selecting a computer providers. But as it comes to all this usage, right, this cloud services, the main concern in the business aspects would be the cost. So if there is a situation where the cost is cheaper and it doesn't compromise the quality, then of course the cost saving would be the first approach in the terms of business venture. So thank you. This is from my side. Thank you.
Thank you for your presentation. My question very simple. If you are going to become a cloud service provider, cloud application, software as a services developer, let's say you're going to develop your application and then put it on the cloud, which provider are you using? Alibaba or Microsoft?
Okay. First of all, I would come to an analysis where let's say now I am creating an app in terms of business, right? So the first thing is, one is the number of users and its potential number of users it's going to go, and of course the capacity of like what's its capacity, the amount of data for it to store. But I would personally go for the cost saving. As a startup, I would look at something which is more cost efficient. So in that terms, I would say that I would go for Alibaba. But as I said, that there are also certain functionalities wise that what's that, quality wise, it's shown that Azure has a better quality. So if there is a term where I can compromise the cost but performance is as equal, then I would definitely go for Alibaba.
How about if your development environment, are you using Microsoft more or Unix more?
Microsoft.
So maybe your development environment will influence you as well.
Like as we see that for personal users, definitely all of us, it's like when we purchase a laptop, Microsoft is already built in. But in terms of the corporate sense, a sense of working there, it's like generally they use Unix environment for, it's like all our daily task routine. So it depends on, it's like the flexibility. So in terms of user friendliness, I think since all of us had the exposure of, Microsoft since.
What I mean, if the company, they are using Microsoft solution,
Okay.
then that might influence them to adopt to Microsoft Azure.
Okay.
If they are not using Microsoft solution, they are more to open source or whatever, then they are more open to different software vendor, more cloud service vendor. Even though Microsoft also provide open source, but they are always close the open source by having modified the open source code. So these are common practiced by Microsoft. They also have MapReduce, but they call different name. They also have a NoSQL database, but they call different name, right? But they use the same technology. I think also Alibaba also doing similar. But for Microsoft, they are when they open in terms of openness, they are
Okay.
not so open. But
Okay.
if you close to Microsoft,
Mhm.
the company close to Microsoft, then there's no issue because all the solution they are using in Microsoft, like SQL Server, they are using Microsoft Visual Studio. Then they can use Visual Studio Code instead of Visual Studio. They also can use Visual Studio to develop. Then you can easily upload and download the code to Azure environment.
Mhm.
So it's well integrated. These are also one of the criteria when you make a decision.
Okay.
Okay, thank you.
Thank
This
you.
is
Thanks.
my comment. This is my comment lah. Depend on how the influence is not only price lah.
Okay.
Sometimes also the company culture
Mhm.
will affect it. But you as a developer, maybe you just the most important thing is the price first. Then you go
Yeah.
for whatever, which is the cheapest. Make sense?
I agree with you,
Okay.
sir.
Okay. Thank you.
Thank you,
So
sir. Thanks a lot.
Ibrahim Abba, you want to try the last
Yes,
one?
yes, let me try it, Doctor.
Cannot lah. Didn't see anything. Okay.
Joe?
Okay, you can start.
Okay, good evening, everyone. I'm here to present my assignment on Microsoft
So
Azure.
quick and fast. Quick and
Okay,
fast.
Microsoft Azure and the Google Cloud. First and foremost, before I go on, I'd like to introduce what the cloud computing is. A cloud computing is a model for enabling convenient, on-demand network access to a shared pool of configurable computing resources, e.g. the networks, servers, storage, application, and services that can be rapidly
Skip.
provisioned. Okay, cloud services refer to computer resources delivered such as the application platform, infrastructure, storage, computational. Delivering application and services over the internet, such as software as a service extended to the infrastructure as a service.
Go to
Example is
the point. Go to the main
okay.
point.
The Microsoft Azure is a public cloud platform that allows the user to build and develop web applications while they store data in the Microsoft data center. The services provided can be categorized as follows. One is the cloud application, data management, network identity, access control, messaging, Azure platform support. The advantages of the Azure, Microsoft Azure are high
Can you go to a
availability.
full screen? Full screen.
Okay, sorry, it's a bit slow.
Because of your network or what?
Yeah, there is network issue.
Never mind. Never mind. Go
Okay,
like this.
all right. Talking about the advantage of the Azure, one is the high availability. Then, it's even here. High availability, data security, and it is cost effective. The scalability. Then the disadvantages include there is required platform expertise. Then requires management. And the second one is the Google Cloud Platform, which started in the year 2011, and since its beginning, it has accumulated many important partners such as the Airbus, Coca-Cola, HTC, Spotify, and so on. Most notably, Equinix, Intel, and the Red Hat. Google Cloud Platform also offers storage options such as MySQL database, Cloud Data Store, cloud storage. Each of the above mentioned storages are available at separate pricing slabs calculated in the unit of
Okay, next.
gigabyte amount. Okay.
Next. Because the
Then
time
the
is up already.
all right, sorry. The analysis of the comparison. In general, Microsoft Azure is the most widespread cloud platform among the two. Then Google Cloud Platform provide direct IDE support, namely Cloud9. Then comparing their database and virtualization, Azure provide the least among the database option, while the Google Cloud Platform provide the most. And the pricing between the two, both have customer-specific pricing scheme that depend on the usage. Also, the specification among the two, while Microsoft Azure provide the highest number of ML framework support, the Google platform provide only few. Google Cloud Platform boosts the highest number of runtime, and for their support, both platforms provide a great deal support in the form of forums and documentation. In conclusion, Azure provide a well-rounded set of storage services and features, but can have a steep learning curve, especially for users without background in Microsoft technology. Google offers fewer features but shines in storage, pricing, and ease to use. Thank you.
Okay, thank you. What do you mean both for highest number of runtime? Is it fast or slow?
Yeah,
What
the processing capacity, but it depends on the number of processor that they both use. Both of them have the
but the meaning of highest number of runtime is what? Meaning what? Fast or slow?
fast in processing
So it
capability.
mean it's better like in that sense.
Yeah,
Then so conclusion, you prefer which one?
before conclusion,
Yeah, you prefer in conclusion you prefer which one?
or in
Microsoft
conclusion,
or Google? Microsoft or Google?
it depends on the demand of the company, but most people will prefer the Azure because of the storage capability and the future it offer. Then the
Okay.
learning, yeah,
So
it is.
most people prefer Azure.
Sorry,
Most people prefer Azure
yeah,
than
we'll go
Google.
for the Azure due to the storage capability and the ease to use interface.
You claim that Azure have more people using it than Microsoft, is it?
Yeah, that is in conclusion.
So what is the market share now? Who are number one? Who are number two? Who are number three? Who are number four?
Oh, in in the share, I think Microsoft is ahead of the
In
Azure.
terms of market share of cloud service provider.
The current share, I'm not sure of the highest.
How many percent in the market share for Azure and how many percent in Google? Can you Google
Okay,
and then you tell me?
all right.
Okay, you stop sharing.
Okay,
Okay, so now question go back to just now. Can you tell me the answer just now? The
okay.
MongoDB one, who's doing MongoDB and Cassandra? Hello?
Hello,
Is
sorry.
it? Yeah. So what's the answer between Cassandra and MongoDB? The answer is 5 document or 1 document just now. Who is supposed to answer that question? Hello?
Hello, yeah, I'm still on.
Then what's Ibrahim?
Sorry. Yes,
You are
sir.
not you are not you are market share, right? You are Microsoft and Google, right?
Yeah, Microsoft and Google Azure.
You are not the Cassandra and
No, no, no.
MongoDB.
Mine is not on Cassandra.
Who just now who are presenting that? Cassandra and Mike and MongoDB. Who's presenting that just now? Tayub or
Me, doctor, me, the you.
so why you don't answer me? Can you
Sorry,
give the answer?
you tell me that next week. I will
I
order
ask you to Google after the next presentation, Ibrahim Abba. After the next presentation, you tell me.
Okay, sorry.
Why take so long to tell me the answer? Ibrahim, did you get the answer? Market share?
Yeah,
Can you share a screen or you can market share of the market leader? Who better?
Professor.
Yes.
yeah, Prof. Based on the, can I share the screen?
Yeah.
Okay. All right, based on this information, I got that the cloud services market share in the first quarter of 2020, the top three cloud infrastructure providers were the AWS 33% market share, then followed by the Microsoft Azure 21%, and Google Cloud is 8%. So it seems like the Microsoft Azure is ahead of the Google Cloud.
Ah,
Yeah.
that's the thing I like you to support when you say more and so on. Right?
Okay.
Azul, then you should give me the market share.
Okay.
Why I say more people are using it because they are number 2.
Yeah.
Okay.
Yes.
But this one not include Alibaba.
Yeah.
Okay.
That's not
Actually,
Alibaba. Yeah.
Alibaba is coming up,
Okay.
but because of the trade war, then
Yeah.
the market share might shrink a bit
That's
because
it.
the Alibaba I think is number 1 in China.
Okay.
Okay.
All right.
So these
Thank
are
you.
at least when you present, then you get a better picture. Okay.
Okay. All right.
So
Thank
I
you.
think that's all for today. Or Dayub, you want to answer next week, right?
Yes, Professor.
Or
It's
you have an answer now?
it's on one file, but I don't know how the load is fixed. But but it's in one file for
It's in
for 5 employees or 5 or 6 employees. It's one file,
it's on one file, right?
right?
Okay. So my question is, next question is on one file. Let's say I modify the student, I add one more student. Do
Yes,
it preventing other from reading the students? Let's say initially I have 10 students. Now I
okay.
add one more student to the document. Did it prevent other from reading
Prevent other
this document because somebody are writing it? Do we preventing other from reading?
from reading. No, no. From writing just one. From
Yeah
reading, no.
lah, writing just one, but reading can be for many. But
Yes.
the moment I make more changes, do I prevent others from reading the file? Because it's from same file. I modify it. When you modify it, you should lock concurrency control, right?
Uh,
If you not lock, different people will see different things.
yes.
So this might be the issue.
Okay. I will Google it
Right.
and
This might be an issue, right? Do you
yeah.
understand my question?
Sorry.
Do you understand my concern, my question?
No, that's the second one. No. If
Second
if
one is,
if
let's say
there's
one,
one,
for
okay.
example, let's say you have one file, everything in that file. You modify that file. When you modify that file, during modification, usually you don't allow people to read or write same time because you lock it, you modify the content. Those that read the content might be get obsolete content. So usually you have read lock also. Some you don't care, you don't lock, mean the people, anyone can read, but when they read, somebody might read the old file, somebody might read the later file if you not lock it. Okay, because you make modification to the file, because at the file level. But if the file is very big, and then they can lock it at the section level on the file, then of course those that section that not change, then people can read it. So it may be the whole file is not at file level, they can at the record level at the file, because they write into the same file. Okay, that's my concern lah. If they are they write file record all in the same file, then do they do a concurrency at the file level or record level at the file? If a record level, then they will not affect any read, because any read will not change. Other record that in the file will not change. So they can read because they are record level at the file. But it's a file level, they cannot read because the whole file be modified. You get what I mean?
Yeah.
This is a more final question, more new to that. Okay.
Yes.
So these are the things that when you read something, you need to fulfill your curiosity.
Okay, sir.
Okay, it's not just reading, but you need to fulfill your curiosity on the knowledge. That's what when I ask, it's also based on curiosity. Okay.
Okay,
Me,
sir.
I'd like to know more, right? Okay, I
Okay,
think
sir.
thank you for your this one. For those that not present, we continue next week. Okay.
Thank you,
So
sir.
see you. Bye bye. Remember next week got test, test. Okay. So we will do the test first, then followed by presentation, then followed by lecture. Okay. So see you next week.
Thank you, sir.
Bye.
Thank you, sir. Bye-bye.
Bye.